The National Electrical Code, or NEC, has followed different revision cycles throughout its history. Understanding these cycles is important for electrical professionals to stay current with the latest safety standards and regulations. Since the 1996 edition, which was released in 1995, the NEC has been on a 3-year cycle. This means a new edition of the code is published every 3 years, incorporating updates, revisions, and new requirements. Prior to the 1996 edition, the NEC operated on a 6-year cycle. This longer cycle meant that new editions were released every 6 years. Specifically, editions were released in 1956, 1962, 1968, 1975, 1981, 1987, and 1993. The change from a 6-year cycle to a 3-year cycle represents a significant shift in how the NEC is maintained and updated. The shorter cycle allows for more frequent incorporation of new technologies, safety practices, and industry feedback. This helps ensure that the NEC remains relevant and effective in addressing emerging electrical hazards and challenges. The NEC development process involves a rigorous review and revision process. The National Fire Protection Association, or NFPA, sponsors the NEC and oversees its development through a committee structure. These committees are composed of volunteer experts from various sectors of the electrical industry, including installers, manufacturers, inspectors, engineers, and researchers. The process begins with the submission of proposals for changes to the existing code. These proposals can come from anyone, including individuals, companies, and organizations. The proposals are then reviewed by the relevant code-making panel, which is responsible for a specific section or article of the NEC. The code-making panel considers the technical merits of each proposal, as well as its impact on safety and industry practices. The panel may accept, reject, or modify the proposal. The decisions of the code-making panels are then subject to public review and comment. This allows for further input from stakeholders and helps ensure that the final code reflects a broad consensus. After the public review period, the code-making panels meet again to consider the comments received and make any necessary revisions to their decisions. The revised code is then submitted to the NFPA Standards Council for approval. Once approved, the new edition of the NEC is published and becomes available for adoption by state and local jurisdictions. The adoption of the NEC is not automatic. State and local governments must specifically adopt the code into law in order for it to be enforced. This process can vary from jurisdiction to jurisdiction. Some jurisdictions adopt the NEC statewide, while others allow local governments to adopt it on a local basis. Additionally, some jurisdictions may adopt the NEC with amendments, meaning they make changes to the code to suit their specific needs and circumstances. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It provides detailed requirements for the safe installation and maintenance of electrical systems. The code is organized into chapters, articles, and sections. Chapters provide a broad overview of a particular topic, while articles provide more specific requirements. Sections provide the most detailed instructions and specifications. The NEC uses a numbering system to identify specific requirements. For example, Section 210, 12 addresses arc fault circuit interrupter, or fire protection. Section 250, 50 covers grounding electrode systems. And Section 300, 11 addresses securing and supporting wiring methods. Understanding the numbering system can help you quickly locate the specific requirements you need. In addition to the main text of the code, the NEC also includes a number of informative annexes. These annexes provide additional information and guidance on various topics. They are not part of the enforceable code, but they can be helpful in understanding the intent and application of the code requirements. For example, Annex A provides a list of product safety standards, while Annex B provides examples of conductor and capacity calculations. Annex C provides conduit and tubing fill tables, and Annex D provides examples of residential load calculations. The NEC is constantly evolving to keep pace with new technologies and safety concerns. Some recent changes to the code include updates to requirements for energy storage systems, electric vehicle charging equipment, and surge protection devices. The NEC also includes new requirements for the installation of small wind turbines and solar photovoltaic, or PV, systems. Staying up to date with these changes is essential for electrical professionals to ensure they are providing safe and compliant installations. One of the key concepts in the NEC is the concept of ampacity. Ampacity is the current carrying capacity of a conductor. It is the maximum amount of current that a conductor can safely carry without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the size of the conductor, the type of insulation, and the ambient temperature. The NEC provides ampacity tables that list the ampacities of various conductors under different conditions. These tables can be found in Article 310 of the NEC. It is important to select conductors with adequate ampacity to ensure that they can safely carry the expected load current. Another important concept in the NEC is overcurrent protection. Overcurrent protection is the protection of electrical circuits and equipment from excessive current flow. Overcurrent can be caused by a variety of factors, including short circuits, ground faults, and overloads. The NEC requires that all electrical circuits be protected by overcurrent devices, such as circuit breakers or fuses. These devices are designed to automatically interrupt the flow of current when an overcurrent condition occurs. The size of the overcurrent device must be properly selected to protect the circuit from damage. The NEC provides guidelines for selecting the appropriate size of overcurrent device for different types of circuits and equipment. Grounding is another critical aspect of electrical safety. Grounding is the connection of electrical circuits and equipment to the earth. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip overcurrent devices and prevent electrical shock. The NEC requires that all electrical systems be properly grounded. The grounding system must be designed and installed in accordance with the requirements of Article 250 of the NEC. The NEC also includes requirements for bonding. Bonding is the connection of metallic parts of an electrical system to create a continuous electrical path. Bonding helps to ensure that all metallic parts are at the same potential, which reduces the risk of electrical shock. The NEC requires that all metallic parts that are likely to become energized be bonded together. These parts include metal conduits, metal enclosures, and metal equipment housings. The NEC also includes requirements for wiring methods. Wiring methods are the ways in which electrical conductors are installed. The NEC recognizes a variety of wiring methods, including conduit, cable, and raceway. Each wiring method has its own specific requirements for installation and support. The NEC also includes requirements for the use of specific types of conductors and cables. It is important to select the appropriate wiring method for the specific application and to install it in accordance with the NEC requirements. The NEC also addresses special occupancies. Special occupancies are locations that have unique electrical hazards or requirements. These occupancies include hazardous locations, healthcare facilities, and places of assembly. The NEC provides specific requirements for the electrical installations in these occupancies to address the unique hazards and requirements. For example, hazardous locations are locations where flammable gases, vapors, or dust are present. The NEC requires that electrical equipment installed in hazardous locations be specifically designed and approved for use in those locations. Healthcare facilities have specific requirements for the reliability and safety of electrical systems to ensure the continuity of patient care. The NEC provides requirements for emergency power systems, essential electrical systems, and patient care areas. Places of assembly, such as theaters and auditoriums, have specific requirements for lighting, emergency lighting, and fire alarm systems. The NEC provides requirements to ensure the safety of occupants in these locations. The NEC is a complex and comprehensive document. It is essential for electrical professionals to have a thorough understanding of the code to ensure they are providing safe and compliant installations. The NEC is updated every 3 years, so it is important to stay up to date with the latest changes. There are a variety of resources available to help electrical professionals learn and understand the NEC. These resources include training courses, seminars, and online resources. The NFBA also publishes a variety of NEC-related publications, including the NEC Handbook and the NEC Analysis of Changes. These resources can be valuable tools for understanding and applying the NEC requirements. In addition to the NEC, there are other electrical codes and standards that may be applicable to specific installations. These codes and standards include the National Electrical Safety Code, or NEC, which covers the installation and maintenance of electrical power and communication lines. The International Electrical Code, or IEC, is a set of international standards for electrical installations. And Underwriters Laboratories, or UL, standards are product safety standards that are used to evaluate the safety of electrical equipment. It is important to be aware of these other codes and standards and to comply with them as applicable. The NEC is an essential tool for ensuring the safety of electrical installations. By understanding and applying the requirements of the NEC, electrical professionals can help to protect people and property from electrical hazards. Staying up to date with the latest changes to the NEC is crucial for maintaining a high level of safety and professionalism. The NEC is a living document that is constantly evolving to meet the challenges of a changing world. The 3-year cycle ensures that the code remains relevant and effective in protecting people and property from electrical hazards.